Okay, today we're going to solve systems of linear inequalities. Okay, how do we do that? Well, this is very similar to what we did with systems of linear. You guys remember? Equations. That's what we've been working on all this time, right? You guys remember? And we learned many different methods. What was our first method? By Matthew? Graphing. Second method? Yes. No. Substitution method. And third method that we liked was the addition method, right? Now, to solve systems of linear inequalities, it's very much similar to solving systems of linear equations. Okay? By the way, inequalities. You guys remember what inequalities are? They have these symbols, right? Less than, greater than. Okay, alligator. But mathematically, less than, greater than, less than or equal to, greater than or equal to, instead of equal sign. So instead of equal sign, if you have these, so that's what it becomes an inequality. So I'm going to show you this. Let's do an example. It's sort of a review. I want you to solve systems of linear equation by graphing, and notice we have equal sign. Now, if I were to replace them with inequality symbol, guess what? It becomes systems of linear inequalities. Okay, that's all. But let's do this first because they're really similar. If you know how to do this, solving systems of inequality is very similar. Okay, it involves doing this, and then you got to do something. So first, do this. You guys remember how to solve this using graphing method? Yes. Okay, so first you got to change both of them into which form? Slope intercept form. Then you grab them and look at the intersection. You guys remember that? Yeah. Go ahead, everybody try. I'll wait. Alright, so Tajwar, tell me what to do for the first equation so I can write this in slope intercept form and graph.
You subtract the x.
Yep.
And then you divide by -1.
Yeah, because it's -1y times this. Did you all get y goes to x minus 2?
Yeah.
What is the y-intercept? -2. I said b sub -2. Is that okay? What's the slope of this line? No, it's not x. Slope, it's 1. It's the coefficient of x. Be careful. What number is multiplying x? That's the slope, right? The number multiplying x. So slope is, I wrote 1 over 1 because, you go up 1 to the right 1. You guys remember? All right, for the second one, what do we do, Aiden? Second equation. I want to get the y by itself, so
2y equals -x plus 2.
You got it. And then divide both sides by? Yeah. How many forgot y equals to -half x plus 1? Easy enough? Somebody tell me the y-intercept of the second equation. Yes, Chris? 1. What's the slope, Chris? -half. By the way, I like to do the y-intercept first now because why do you think I do y-intercept first? Right. Why do you think I write y-intercept first rather than slope? Because when you graph, what do you graph first, guys? Y-intercept. Okay, don't put. Because if you put slope first, you may think that's y-intercept or something. Be careful like that. All right. So here, let's graph the first. I'm gonna use blue for the first one. Is that okay? And then I'm going to use red for the second one. All right. So blue. Where do I start? Again, I always start at the y-intercept first. I can't start with slope, can I? Because slope. There's too many lines with. There are infinitely many lines with slope of 1. I'm gonna start at -2 right here. And then I go up 1 to the right 1, up 1 to the right 1, and so on. So all I have to do now is connect. There you are. Here's my first equation. The second equation, somebody tell me what to do. How about Angel? What do I do? I start at 1. Good, that's the y-intercept, right? And then what? What's my slope? -half, which means -1 over +2. So I go down 1, right 2. And as you can see, down 1, right 2. I could do that again. As you can see, the two lines will intersect at 2, 0. Now, we could have done this using substitution method or addition method, but the reason I'm graphing it is because, like I said before, in order to solve systems of linear inequalities, which method do you need? You need to do it by graphing. Okay. Anyway, so let's write our solution. What's our solution? 2, 1. I mean, not 1. 2, 0. Okay, there it is. Easy enough? Yeah. Okay, so it turns out to solve this system, so all I'm going to do now is replace the equation with some inequalities. Is that okay? Do you see what I'm going to do? So here we go. Here's our first example of systems of inequalities. So you could find the solution set of systems of inequalities by graphing. Okay, so here is example 1. Instead of equal sign, no, for the first equation I have greater than. For the second one I have greater than or equal to. So go ahead and write this down. Okay, there you are. So it says you can use graph to find the solution set of system. As a matter of fact, only way to find the solutions to the system of inequality, you have to graph. There's no other way. Okay. So how are we going to graph inequalities? Well, some of you might remember from last year, but if you don't worry about it. I'll go over it. So first, we're going to treat them as if we have equations. In other words, we're going to treat them as if we have equal sign in the middle. But whenever you have inequalities, okay, and so we're going to solve for y again. To write this in which form? Which form do we like? Yeah, y equals slope-intercept form, right? So we're going to treat these inequalities as if we have equal sign and solve for y and write it as in slope-intercept form. Does that make sense? So here's what I'm going to do here. Look at the first equation. How do I solve for y? Subtract x from both sides. Now, but do you guys remember for inequalities? You could treat this as if an equation, but inequalities you got to be careful. Whenever you multiply or divide both sides by something, you have to reverse the inequality symbol. You guys remember this from last time? When do we reverse the inequality symbol? That's the only thing that's different than an equation, right? Whenever you deal with inequalities, when you multiply or divide by what sort of number do you reverse? Say it again. Negative number is correct. Samuel is correct. So you guys remember, whenever we have inequalities, you treat it as if you have an equation, but then you do the same thing, right? You could add both sides by the same number, subtract, multiply or divide. But whenever you multiply or divide by negative, you reverse. What about if you multiply or divide by a positive number? Do you reverse? No. What about if you add both sides by a negative number? Do you reverse? No. What if you subtract both sides by a negative or positive? Do you reverse? No. Only time you reverse the inequality is when you multiply or divide by what kind of number? Negative number. Do you guys remember this? Okay, so let's do that. First, we're going to, just like we did before, we're going to subtract x from both sides. And now we get negative y equals, not equal, greater than negative x plus 2. Now, what am I going to do? I'm going to divide by negative 1. Whenever you divide by negative number or multiply, what do you have to do with the inequality symbol? You need to reverse. Somebody tell me what to write. So what does this become? Let's see if you got what I'm trying to say. What does this become? Yes, Jason?
Y is less than minus.
Exactly right. Do you see how the inequality reverses? You guys remember this from last year? So that's the only thing that you got to be careful of whenever you deal with inequalities, okay? You reverse it when you multiply or divide by negative. Let's do the second one, okay? All right. All right, so the second one then, we're going to, of course, subtract x from both sides. We get 2y, just like before. It's the same exact equation, right? 2y is greater than or equal to, negative x plus 2. And we're going to now divide both sides by 2, correct? Do we reverse? No, we're dividing by what kind of number now? Positive. We don't reverse when you divide by positives. And so we get this. Does that make sense? So now, how do we graph it? Well, you graph it as if you have equal sign in the middle. I'll show you how to deal with inequalities in a minute. So you're going to graph as if you have y is equal to x minus 2 and y is equal to negative half x plus 1. So let me show you what to do. Here you go. So we're going to graph them as if you have equal sign in the middle. By the way, when you write this as, when you rewrite y, instead of inequality, just write y equals to x plus minus 2. And then y is now equal to negative half x plus 1. You get 2 lines, right? These lines are called boundary lines, okay? So let me show you what I mean by that. So let's graph that boundary line. This is going to be important. So this boundary line, first one, is the same exact line we did before, right? What's your y-intercept? Negative 2. What's your slope? 1, as before. So we could start at negative 2, and our slope is 1, go up, right 1, same thing. Now for this line though, you notice my inequality, you see how it was just less than? Was there less than? It didn't say less than or equal to, right? So this boundary line, I'm going to dot it. I'm going to draw it as a dotted line, like this. How come I'm not going to draw a solid line? Anybody have an idea why?
Because it's not,
Oops.
the line is not included
Okay. Yes, very good. You guys remember from last year? This means that this inequality does not include this boundary line because it only says what? Less than. Does that make sense? So you see this boundary line? Look at my inequality. It says y is less than x minus 2, right? So this, if it said y was less than or equal to, then you include this line. It just says y is less than. Does that make sense? So it does not include where y is equal to x minus 2. Does that make sense? But what do you think we mean by y is less than x minus 2? Y is like how high something goes, right? So if it's less than, guess what? It's going to be below. So it turns out in this inequality, all these order pairs, you see how the boundary lines divides the whole thing into quadrant into two sections, two different regions. It's the bottom region that this inequality is a solution of. Okay, but it doesn't include the boundary line because it says y is just less than. So less than means lower, right? So on the bottom. If it said y was greater than, guess where we shade? It'll be above. It means every order pair above this line will be a solution. In this case, it'll be every order pair, right, below this line. Does that make sense? So you guys remember this from last year? Now, what about for the other one then? This one is greater than or equal to. So let's draw our boundary line. Oh, wait, as a matter of fact, I should have done this with what color, guys? Blue. So
Why blue?
because I did it on the other one. So can I just change it to blue, if you don't mind? There you go. Isn't that nice? I could do that. All right, then I'm going to do this one in red. Okay, let me change. Here, what is my y-intercept? 1. What's my slope again? -half. So I start at 1, and I go what? Down 1 to the right 2. Again, the same thing. Now this time, will my boundary line for the second equation solid or dotted?
Solid.
Solid because it said what? It was said, yes, it said greater than or equal to. So now it's going to be solid, and it's because it says y is greater than or equal to, right? When you say greater than or equal to, well, this is equal to, y equals to this. That's the line, right? Does that make sense? Now, do we shade above or below? It says now y is greater, so do we shade above this line or below? Y is greater, so it's going to be? It's going to be where? Above or below? Above, right? Does that make sense? So it's every order pair that is above this line, including the boundary line, because it says y is greater than or equal to. Does that make sense? So, this is how you show the solution. Am I done showing the solution? Not quite. You guys remember, for linear equations, the solution was where the two lines intersect, right? Guess what the solution for the inequality is? Where the regions intersect. Shaded regions intersect. So, do you see how this region right here is our solution? Right? Do you guys understand? How many order pairs does this region have? Infinitely many. Okay. So that's what we mean by solution of systems of linear inequalities. Inequalities give you regions as a solution instead of, right? So when the regions overlap, that's where the solution lies. Does that make sense? It's very similar to equation of lines, isn't that right? But now you're selecting regions, okay? Because of less than or greater than symbol. Okay, so does that make sense?
Yes.
Okay, now let me ask you this though. So if somebody said, okay, here's the region. Now if somebody said, is 4,0 a solution to this systems of linear inequality, what would you say?
Yeah.
4,0, yes. What about 5, 1?
Yes.
What about 6, -1?
Yes.
Now what about, here's an interesting one. What about the point that is on this blue line? 4, 2. Would that be a solution? No, because it's on the dotted line, right? Because it's a solution to the red, but it's not solution to the blue. It's got to be solution for both. What about then 4, -1?
Yes.
Yes, it is. Because 4, -1 is solution to the red, but it's also solution to the blue. So it's a solution. So then what about this intersection? 2, 0. How many people say yes? How many people say no? I want you to discuss. Will the point 2, 0 be a solution to this system or not? Think about it. Remember, in order to be a system, solution, it's got to be solutions to both, right? So what do you guys think? So how many people think that, raise your hand, how many people think that 2, 0 is a solution to this system? How many people say no, it is not? You guys are correct. Why is this not a solution? Matthew?
Because the boundary line is included in it.
It's not. What do you mean by that? So 2, 0, it is solution to the red, isn't it?
Yeah.
Is this solution to the blue? No, because blue is dotted, right? Anything on the boundary line on blue is not a solution because we don't include the boundary line because it only said less than. It didn't say less than or equal to, did it? Does that make sense? Right here, right? It says y is less than x plus 2. X minus 2. Do you guys get the idea? Alright? Let's do a couple more examples then. Okay. So that's a good question. When we do this on your homework, what are you gonna write as your homework? Answer for this. If I ask you to solve this system, how are you gonna show me the solution? Yeah. What's the solution to this? The system. Yes. The shaded area. That's your solution. You have shown me the solution. Yeah, just this. Yeah. Because why is it just a graph? And why do I say you could only do this with graphing? Can you list all the points that is on this region? No. Can you write it out? There are infinitely many. That's why we do it as a graph this way. Okay, so where they overlap, you either highlight it with a highlighter, or you like kind of mark it differently with your pencil, saying that this region where they overlap is your solution. Does that make sense? All right, good question. Another good question is, will there be a time when you get no solution? Yeah, when the two regions do not overlap, right? So if the two regions don't overlap, right, then you get? Yeah, the two boundary lines will be parallel, and then there will be no solution if they don't overlap. Okay, so for these inequalities, overlapping region is your solution. Whereas a system of linear equations, intersection is the solution. You guys, do you see the difference? Okay, very good. Here we go. Let's move on to the next one. Okay, here we go. So let's look at this one. This example is kind of interesting. It's very simple. It just says y is greater than 1, x is less than 3. And we're going to graph this on a coordinate plane and solve the systems of linear inequalities. So let's first of all look at our boundary lines, okay? We're going to get lines, right? We're going to get two lines. What's the line that we get for the first equation? No, what's the equation of the line that we get for the first equation? Y is equal to 1. It's easy. All you have to do is replace inequality with equal sign. What about the other line? What's the line? X equals to 3. So can I just write BL for the boundary line? Is that okay? Now, some of you had a question. Jason, will you get dotted line or solid line for the first equation? The first inequality when you graph. Would it be dotted or solid? It'll be dotted. How do you know? Exactly. It just says y is greater than, right? My inequality. What about the second one? Michael, it'll be dotted. Why? Because? Yeah, it just says less than. It doesn't say less than or equal to, right? So every time you have less than or greater than, it's going to be dotted. If it's less than or equal to, if it's less than or equal to, greater than or equal to, you get solid. You get the idea? Because we don't, they're saying, in this case, we don't include the boundary lines. If you say greater than or equal to, then or equal to part is the boundary line. Does that make sense? Now, do we know how to graph these lines? Boundary lines? You guys remember how to do these? Y equals 1. What kind of lines do you get? You get a horizontal line. What kind of lines do you get for x equals 3? Vertical. If you forgot, can I do a little table? Yeah, this is a good idea to do a table. It's really easy. If y is always equal to 1, y is fixed, right? And so x could be anything you want. Do you see why you get a horizontal line? For x equals 3, x is fixed now. You could have any y's you want. Do you see how we get a vertical line? Go ahead and everybody graph and tell me the solution of this system. I'll wait. Go ahead. Help each other out too. Go ahead. Everybody try. Okay, so for the first line, y greater than 1. Let's graph that one. Let's do that in blue just like before. Somebody tell me what to do. Y greater than 1. The boundary line is y is equal to 1. Again, we get a what kind of line? It's going to be dotted. What kind of line would this be? Horizontal or vertical? Horizontal. If you're not sure, look at the table. I get -1, 0, -1, 1, 0, 1, 1, 1. So you get a horizontal line right there. It's going to be, again, we said it's going to be dotted because it says strictly, y is greater than, right? There you go, okay? All right. Okay, so that's that. And what about for the, which way should we shade? Y is greater than 1, so greater than means, is it above or below? Above, right? Easy enough? Yes? Okay, here we go. So I'm going to do that. Now, what about for the other one? X is less than 3. Well, let's plot those points. 3, -1 is right here. 3, -1, 3, 0, 3, 1. So I get a dotted line. Now, this time it's kind of interesting. Because how do you do a above or below for vertical line, right? You can't do that, right? But look at what it says. X is less than 3, right? Where are all the values of x that are less than 3? Left of it or the right side of it? Left side of it. So guess what? We shade where? Left side. Because it says x is less than 3. Everything, right? All the values of x that's less than 3 is going to be left of 3, not right side of 3. That's obvious, right? Now, am I done? Or do I need to shade now? Claire, do you see where our shading region is?
Yes.
Where is it?
It's above 1 and left of 3.
Exactly. So this region right here is going to be your solution. Some of you say, where's your solution? Right there. That's what we're doing. That's what we're doing. So that region, every point on that region is your solution to the system of inequalities, right? What about any point on this dotted line, red one? No. What about on the blue one? What about where they intersect? Of course not. They're both, right? Not included. This time it's pretty clear. Does this make sense? Okay, let's do one last one. This time they kind of do it opposite. They give you the graph. They ask you then, give me the inequalities that you get from. But it's not easy. It's not that hard. It's easy. Here we go. So it says, write the system of linear inequalities whose solution set is shown below. So here, in the shaded region. There you go. So it's kind of doing it backwards. We give you the systems of, we give you the graph of systems of linear inequalities. And this is the region right down here. So what can you tell me about in terms of red? Is it going to be above or below the red line?
Below.
Below, because it's got to be in this region, right? So we know it's going to be this, right? Do you understand? What about for the blue? So if they give you this, if this helps you, you could do that, right? Just yeah, and then is it going to be on the right side or left side?
Right.
Yeah, that's the only way to get that region, right? So that helps us to figure out, right, these inequalities. So we have to look at the boundary lines, correct? The boundary line of the red or the blue, that's what you need, right? So for the blue one, what is going to be the equation of the blue line? Okay, how about Chuck?
Y
Mm-hmm.
greater than 2.
You sure?
Greater than or equal to?
No. It's great. It's going to be greater.
No.
But is it y or is it x? X, because look at x is fixed. X is always 2, right? Y could be anything you want. You see what I mean? Look at every point on this boundary line. X is always 2, and that's how you get a horizontal line. I mean vertical line, right? So yeah. So the boundary line for the blue is x equals 2, correct? So we know it's going to be x is going to be what? X less than 2 or greater than 2? So it's going to be x. Yeah, x is greater than 2, right? That's the inequality we need, right? X greater than 2. You understand? Because we shade it to the right side. For the other one, for the red one, we know that it's going to be a line, right? So what's the equation of this boundary line? Because once you know, you're done, right? So y is equal to what's your slope? I mean, what's your y-intercept? 3. What's your slope?
2.
Is it 2 or negative 2? Pick 2 points that are nice. You go down 2 to the right one. So slope is, yeah, slope is negative 2, isn't it? Be careful. So remember how to find the slope from the line? You pick any 2 points you like that are nice. Figure out how much you have to go up and down and to the right, left and right to get to that point, the other point. So that's it. And so somebody give me the equation of the boundary line. Yes.
Y is less than or equal to 2x plus 3.
The boundary line is y is equal to 2x plus 3, negative 2x plus 3, right? Now from here, yes, is it going to be less than or greater than? It's got to be, it's below the line, so it's going to be less than, or is it less than or equal to, or just less than? Less than or equal to. So there you go. So to write the inequalities, there you are, we found it. It's going to be y, so you start with the boundary line, right? And then you just decide whether or not, is it going to be less than or greater than, and then whether you should include the boundary line or not. So first one, x is greater than 2, the red one, y is less than or equal to 2x plus 3 are the inequalities for this. Does that make sense? Easy enough? Can you do something like this for your homework tonight?
Yeah.
Very good. On your homework tonight, they don't just give you a system, they only give you one of them. So sometimes they just give you one. Is that okay? That's even easier, isn't it? So sometimes they don't give you a system, they just give you one, and they ask you to graph the inequality. It's just right? It won't be a system. So it'll be either above the line or below the line. If they give you a system, then you look at where the regions overlap. Easy enough? Okay, very good.